Hi, this is Richard C. I'm a math tutor here at Wyzant, and we have some unit circle problems here. They're short and quick. We'll get through them quickly, but there are two approaches to the unit circle. One approach is to just memorize it, um, and in lower levels of pre-calculus, sometimes the teachers will even hand out a unit circle for you to refer to when you're taking a test. The other way to approach it is special right triangles. So I'm going to show you both ways, and I want to just put, I think I'll start by doing some special right triangles, because the basis of the unit circle flows, everything on the unit circle flows from these. So the 30, 60, 90, which is pi over 6 is 30, and pi over 3 is 60. Okay, so this is going to be a 2a, a root 3. And then the 45, 45, 90, which is pi over 4 in radians, pi over 4. That's A red 2. So with that in mind, let's start looking at these. For each one, I'm going to do a diagram. So we're going to label these A, B, so we can kind of keep track, C, D. So we'll start with A here. So the sine is square root of 2 over 2. And we're in quadrant 2. So let's go in quadrant 2. And you might think, well, how do we square root of 2 over 2? Which of these things involves square root of 2? Well, it's the 45, 45, 90. And so if you look at the angle, it's a over a root 2. Well, a over a root 2 is going to be 1 over the square root of 2, which is square root of 2 over 2. So that's how I know, instead of memorizing the unit circle, I know that this has to be pi over 4, this reference angle here, you could put that in there. And so the angle of interest, the answer here is just going to be 3 pi over 4, because the angle of interest is starting here and landing here. Excuse me. Part B, remember this is 4 pi over 4. A good way to think about this is you go 1/2 rotation across to 4 pi over 4, and then come back up 1 pi over 4. That gives you 3 pi over 4. Let's do the next one. Oops. Cosecant is 2, and we're in quadrant 1. So you might want to remember that the cosecant of theta is just 1 over the sine of theta. So this is the same as telling me that the sine of theta equals 1/2. Well, where on these triangles does the sine equal 1/2? You can see it's the 30-degree angle here, pi over 6, because a over 2a is 1/2. That's just SOHCAHTOA, opposite over hypotenuse. And so that's all I have to do. It's pi over 6. Because we're in the first quadrant, there's nothing more to say, so the answer here is pi over 6. Okay. Okay, I'll go on to C. Cosine is negative a half. We're in quadrant 2. Okay. So where are we going to find the cosine to be negative half or 1/2? Well, you can see the cosine of pi over 3 is a half. See, because it's adjacent, a over 2a. So we know we're dealing with pi over 3 as a reference angle. And of course, this is 3 pi over 3 here. So the answer is going to be 2 pi over 3. Okay, it's nice and quick. If you have your reference angles, you're going to need to know, you're going to need to memorize these two triangles anyway, because they're used throughout pre-calculus and they're all over the SAT and ACT, so you really should know these for other reasons. They really help with these kinds of problems that you have assigned. Okay, tangent is square root of 3, and we're in quadrant 3. Okay. Well, the tangent is the square root of 3, so that's square root of 3 over 1. The only place I'm going to find the square root of 3 is in a 30, 60, 90. Here's my 30, 60 again. So for the tangent to be square root of 3, you have to be up here because tangent is opposite over adjacent. So I know my reference angle here is pi over 3, which is here. And the angle is going to be 3 pi over 3 plus one more. In other words, you're going to make 1/2 rotation to 3 pi over 3 and add another pi over 3. And that's going to give you 4 pi over 3. And that's where the tangent is negative root 3 over 1. Now, if you were doing this by memorizing 4 pi over 3 on the unit circle, it has the coordinates negative 1/2, comma, negative root 3 over 2. And so you would find the tangent by taking the sine and dividing by the cosine. So this is negative root 3 over 2 divided by negative 1/2. And that gives root 3 over 1. And so you can find it that way. Some people have a little trouble with tangent because they're relying on the coordinates of the unit circle, but all they see is sine and cosine, sine being here, cosine being here. And so they don't know what to do. And you can see if you just get used to manipulating the x and y coordinates on the unit circle, you can do the tangent that way. Or again, if you memorize your special right triangles, you can see a root 3 is this is the only place where there's a root 3 in the triangles. Okay, so I like doing it both ways. I sometimes run across students who when I start showing them the special right triangles, they just can't believe their eyes. Sometimes the teachers don't cover this. They just sort of just go down the memorization path. But you can see how much faster it is if you can remember these. And you can derive any the xy coordinates of anything on the unit circle just by using these right triangles. Okay, that's it for today. I hope it was helpful. I'll see you again next time. Bye-bye.